Hey year 10, now we're doing 5H, which is solving quadratic equations by completing the square. So we've already solved them by factorising in a different way. Completing the square is another way to factorise because sometimes you can't actually do the method that we were practicing earlier. Now hopefully you remember what a perfect square is. If you don't, that's okay, I'm about to show you. So when we factorise quadratics, we often see stuff like this. Like this is our factorised version. They're not always the same. Like often you'll get something that might look like this. Could be x plus 3, x minus 6. Often they're different. But sometimes, like in this case here, they're the same. Now, something times by itself is just squared, isn't it? So you could write this as that. They are both equal. Now, if you end up factorizing and you see that your answer looks like this, so whatever the factor is repeated, so it's squared, it's called a perfect square. Okay, and they can be really helpful, really important, which we'll see today. Now, as I've got dot pointed here, we can tell if a quadratic expression is a perfect square before we even start factorizing. Now, the way that we do that is we need to look at this rule here. So you might have a number there, a number there, and a number there. Now, if, when you look at it, C is equal to half of B squared, then it's going to be a perfect square. Now, it might be a little bit confusing looking at this. Don't worry too much about it. We're gonna practice here. But basically, you want to see if this, hang on, if you half and square this number, if it's the same as that. All right, let's see. Let's have a bit of a practice. So it says fill in the following boxes to make them perfect squares. All right, so we're looking at this middle term here. We want to half and square it. Half of 2 is 1. 1 squared is 1. So for this to be a perfect square, this C value would have to be 1. Let's go into the next one. Minus 10. We want to half and square it. Half of minus 10 is minus 5. Minus 5 squared is 25. So for it to be a perfect square, we're going to need 25 to be there. Let's do it with the next two as well. All right, minus 6. What's half of that? Minus 3. Minus 3 squared is 9. So if 9's there, it's a perfect square. Last one. 1 is out the front here. So half of 1 is 1 half. 1 half squared is 1/4. Now we've made sure that these 4 examples here are perfect squares, but what we need to know is that if you recognize a perfect square, it's very, very easy to factorize that. Okay, now the way you do it, or the way I like to do it, is it's always just going to be x at the front here. Okay, it has the form x plus or minus something and then squared like that. Okay, now the way you know whether it's a plus or minus in this spot here is if it's a plus there, it's a plus. If it's a minus there, it's a minus. That's going to be minus and that's going to be plus. So because there's a plus there, that's a plus. The thing that goes in here is the square root of whatever that number is. Okay, so number 1. So we've just factorized it. It's as easy and as quick as that. So let's look at the next one. Let's set up our perfect square there. There's a negative there, so it's going to be minus, and I need the square root of that, which is 5. Now you'll notice that if you expand these out, they become the ones above it. If you expand that, it'll become that. If you expand that, it'll become that. Let's do the next couple. Right, let's set up our factorized version. Right, now x, there's a minus there, so it's minus, and the square root of 9, which is 3. Awesome. Next bit here. There's a plus there, so it's going to be plus. The square root of 1/4 is 1 half. There we go. So it's as quick and as easy as that. So now we're going to move into factorizing by completing the square. Now with these two, you might notice that you can't actually factorize it using the methods we were using the other day. So completing the square is something that we might have to do to factorize that. Before we get into that though, I want to look over here. because this is actually a part of what we need to be able to do when we're factorizing by completing the square. So this here, this scenario here, it's called difference of two squares. So this is a expanded version, and this side is a factorized version. Now what we've been given here is expanded versions. We're going to be factorizing them. Again, the reason we're doing this is because you have to do it as part of completing the square. So there's a few steps that we're going to follow later, and you'll see that factorizing using dots is the last step. Alright, so let's actually have a look at this. So it's saying that we've got something squared, don't know what it is, minus something else squared, can be factorized into this. So basically what we're doing is just plugging A into A, B into B. But if we look down here, can you see we've got x squared minus 16? So we've got something squared, but this isn't necessarily squared. I want to change this into something that is. So I'm going to have x squared minus 4 squared. 16 and 4 squared are the same. Now we're just putting our a and b, or our x and 4, into this rule here. So it's going to be a plus b, or x plus 4 in this case. And then in the other set of brackets, a minus b, so x minus 4. That's as simple as it is. Next one, we're doing the exact same thing. So I want something squared minus something else squared. I need to change this. So x squared minus 3 squared, 9 and 3 squared are the same thing. I'm using the rule. So a plus b, or x minus 3, or x plus 3, sorry. And then we need to do the minus. Done. Now this one's a little bit harder because you might see that, like, what's this squared? We need two things that are squared here. This I can't change this easily into something that is squared. But what I can do is this. So I want it to be something squared, don't I? But I want it to be equal. So the opposite to squared is square root. Do you see that if we simplify this, so the square root of, or the squared, if we square a square root, it's just going to disappear because they're the opposite. So this and that are actually the same thing. So this is going to be our a, and then inside here is our b. Alright, so it's going to be a plus b. There we go. And then a minus b. Now if you expand that, you're going to end up getting that. Now you've practiced with the surds so far, so give it a go if you want to. That should be your answer if you expand that out. Alright, let's move over and actually factorize by completing the square here. This is something that some people can struggle with a little bit because they sort of forget the steps. So I'll try to keep it a little bit slow. Now let's just check this here and see if it is a perfect square to start with. If it's not, we're going to try to make one, as it says here in our first step. Okay, so look at this middle term, half and square it. If we half and square that, it gives us 36. If we don't have 36 there. But I'm making a perfect square, so I'm going to write it down anyway. Plus 36. But we can't just write that because they're not actually equal, are they? These aren't the same thing. So I need to actually get rid of that 36 as well, but I can't forget about the 11. Okay, now this here is the same as that, but I want to focus on the perfect square we made at the start. So this bit here, right? Now using what we did before, we can factorize that section. So we can turn it into our x plus minus something squared. Right, there's a minus there, so that will be a minus, and the square root of that is 6. So we've actually factorized this blue section. But again, we can't forget about this stuff here. Okay, so minus 36 plus 11, that's minus 25. Alright, now what you might not notice yet is that this here is actually a difference of two squares that we did before. We have something squared minus, this could be something else squared. So we can change this to x minus 6 squared minus 5 squared. Okay, so do we see how we've got something squared minus something else squared? So we can use that rule. Here's our A and here's our B. So it's going to be x minus 6 plus 5 and x minus 6 minus 5. And that's going to give us x minus 1 and x minus 11. Alright, we've factorised. Now if we were asked to solve, it should have said equals 0. I'm just going to put the 0 in there, and then that'll give us x equals 1 and x equals 11. But it didn't necessarily ask us to solve here. If it did ask us to solve, it might have had that equals 0. Okay, I might actually add that to the next one. Okay, so we're not just factorising, we're solving as well for this next one. Okay, same steps. Let's check if it's a perfect square. If it's not one, we're going to make it one. So, let's look at our middle term. Half and square it. Half is 3, squared is 9. No, that's not what we have. But let's make that perfect square. So x squared plus 6x plus 9. But these aren't the same, that's no good. So I need to take the 9 away, and I can't forget about that 6. Okay, now we want to focus on this bit here, because this is actually a perfect square that we made that we can easily factorise. So remember to factorise that. We've got our x there, it's going to be squared. There's a plus there, so we put a plus in, and we want the square root of that. There we go. Let's not forget about these numbers here. Okay, so minus 9 plus 6, minus 3. And that equals 0. Okay, now this is similar to what we had before. See this example here? It's the same. So we want something squared minus something else squared, but that's not squared. So there we go, now we have it. Okay, so if we expanded that, it still just becomes minus 3. So these two are actually the same. Right, a plus b, and then a minus b. Okay, so a plus b, and then a minus b equals 0. Okay, so we've actually factorised here. That's it, we're done. But if we wanted to solve it, we'd have to make this bit equal 0 and this bit equal 0 as well. So let's do that. So x plus 3 plus root 3 equals 0. So let's solve. Let's get x by itself. So let's move those two things over. There we go. So there's one solution for x. Oops. There's one solution for x. Or we could have this. And we need to move those things over. So that's going to be x equals minus 3 plus root 3. So that's potentially the other solution. Have a go at the questions. Let me know if you need any hand, or a hand.